mathematical induction proofs involving power terms. So as an example we have here, we have to prove that 2 to the power 3n minus 3 to the power n is divisible by 5, and that's what that notation there means with the big vertical line, or in other words 5 divides that expression. That's why it's written that way. So to prove that all of that is divisible by 5, we're going to use mathematical induction, and we know that in the initial step for n equals 1 we have the proposition where we sub in 1 essentially. So we have 2 cubed take 3 to the power 1, and that's 8 take 3 is 5, so that's divisible by 5, so that's true. And we assume, it's a funny A, we assume some n equals k, so we have the proposition P of k, and P of k will be simply 2 to the 3k minus 3 to the k, and we're assuming that's divisible by 5, so we'll say that equals 5a, where a is some integer. Definition of divisible by 5 essentially. So the inductive step here, P of k plus 1, carefully subbing in, so it's 2 to the 3 outside of k plus 1, so that's 3k plus 3 in the index, minus 3 to the power k, and we can use index law 1 to write down an equivalent with the base 2. Sorry, that should be a 3k minus 3 to the power 1 multiplied by 3 to the k. So 2 cubed equals 8 multiplied by 2 to the 3k minus 3 times 3 to the k, and 8 can be split into 5 plus 3. To generate a 5 is a good thing, and also in regards to the 3 we have something else there to the right, a term that has a factor of 3 in it, so both of those things are good. So we want to prove the expression is divisible by 5, and we also have elsewhere a factor of 3 apparent, so 5 plus 3 is a good thing to expand it out to. The subject of that is 2 to the power 3k, and completing the expression, separating that, or expanding it in a sense, we have 5 times 2 to the 3k plus 3 times 2 to the 3k. I'm going quite gently here just so we can hopefully see where all the steps are going. Okay, and then we've got 5 times 2 to the 3k plus that common factor of 3 that I was talking about. You can see that towards the right. So 3 outside of 2 to the 3k minus 3 to the k. Okay, so if we have a look above when we had our assumed n equals k, P of k equaled the value you can see there in yellow, which equaled in turn 5a, and we've generated that down on the latest line we've been working through there. So you can see that we now have something that involves the 5 with the other term, which as you can see is good news because we have to prove the whole thing is divisible by 5. So what we have there is 3 times 5a. we want both terms to have a factor of 5, hence divisibility, and we just use the commutative rule for multiplication there, which is great because then we have clearly a multiple of 5, so hence divisibility that we're looking for, divisible by 5. Because remember, a from before, a was an integer. So a such that a is an integer. So everything inside here is an integer. So we've shown that that inductive step works, it's true. And so some formal statement is required on inductive proofs since proposition is true for the initial step, and when we assume n equals k is true, proposition holds. True for n equals k plus 1. So that's done by mathematical induction. Done.